Hi, this is the second video of showing how to use the AffectiveTweets package. In this video, I will show you how to use AffectiveTweets for creating lexicons. Lexicons, as we showed in the previous tutorial, can be very useful features for training tweet level sentiment or emotion models. But sometimes we want to create lexicons from our own data. This is what I want to show you how to do. So we go to the Web Explorer, and in the first example, I will show you how to create a lexicon from unlabeled tweets. Sometimes we just want to have a very specific lexicon for a specific domain, like sports or politics, and what we want to do is to collect some tweets for these particular domains and then try to create a very domain-specific lexicon. This can be done using AffectiveTweets using a filter called the tweet centroid. So the first thing we need to do is to open a data set of unlabeled tweets. So here we have in packages, same route as before, AffectiveTweets, data. We have a data set of unlabeled tweets that was collected with the Twitter API. So you can do the same thing for your own domain. This is a very small data set for doing what we're going to do. Usually if you want to get good performance, you need to have a bigger corpus. I will say at least 1 million tweets. Okay, so the lexicons we're going to create here are not going to be very powerful. They are just going to help us in an instructional way. Okay, so but try to listen to me a little bit. So the idea here is that we are going to we want to create lexicons from these tweets. So first thing we need to do, and we're going to do this by training a word level classifier. So what we're going to do is try to, from this corpus of tweets, get word vectors. So one vector for each different word. Then we're going to label some of these words with an existing lexicon and use those word vectors and those labels for training a word level classifier that will be deployed on all the remaining unlabeled words. And then for this estimated class for all the words, we're going to obtain a new lexicon that can be used then for classifying tweets in the future if we store this lexicon. Okay, so the filter I'm going to use to create word vectors is called the tweet centroid. So in this filter, what we do is to create word vectors from tweets using the tweet centroid model. Each word is calculated as the average vector of the tweets in which it occurs. This method was published in year 2015 in the conference SIG-IR. Okay, so we need to select the text index. It's going to be 1. Again, we're going to reduce repeated letters, standardize URLs, and also we can reduce a little bit the attribute space and the instance space. So basically, we first need to have to calculate attributes for all the tweets. So we get tweet vectors, and then for each word, we are going to average all the vectors in which the word occurs. So how we're going to create tweet vectors first is using unigrams, so back of words, and we're also going to use word clusters. Okay, and then when we average those tweet vectors for all the different words, we specify a minimum frequency for an attribute to be considered. So yes, this is just to reduce dimensionality here. Okay, I will set this to 4. So I only will consider attributes occurring in at least 4 tweets. And min inst docs will say I only will consider words or instances occurring in at least 4 tweets. Okay, so I'm running this thing, and what I'm obtaining here is going to be now a new dataset in which I will have words as instances. So the number of instances will be changed. You see, now I have less instances. It's one instance per word. So now as the last attribute, we have the word name, which is a string. Okay, so now what I would like to do is that imagine I have used an existing lexicon to label some words by sentiment. So for instance, I know that one word can be negative and positive. So then I can train a classifier using all these attributes to predict the sentiment of a word. Okay, so in order to label words using an existing lexicon, with AffectiveTweets, there is a filter called label word vectors, this one. So in this one, we need to specify the word index, this is the last attribute, and the lexicon we are going to use to label these word vectors. And we can use many, so we will get many different labels. So here we're going to use one particular lexicon called MetaLex that combines many different lexicons and has labels for positive, negative, and neutral. So I'm running this filter, and what I got is now a new feature with the sentiment of the word. So we have negative words, neutral words, and positive words. And I have many unlabeled words because I'm only labeling the words that I calculated using the tweet centroid model that occur in the lexicon. All the other ones remain unlabeled. So what I would like to do is to train a model, a classifier, on the labeled words, and then deploy this classifier on all the remaining unlabeled words. And those predictions are going to be turned into a new lexicon. Okay, so let me show you how can we train. So let's try first to train a word label sentiment classifier. To do this, we can go to the classify panel. Let's use percentage split. And we need to first use the filter classifier because there is a particular string attribute, the word name, that needs to be ignored for training a model. So in Weka, we can use a filter to discard string attributes. So let's go to the filter classifier. Let's go to the filter called remove. Remove by type. We are removing all the attributes of type string. So we are removing the word name. And as a classifier, we're going to use leave linear again, but we are going to use now, instead of an SVM, we are going to use a logistic regression. The nice thing of the logistic regression that we can get probability estimates for the classes, and this is going to be helpful then because we will get then a probability estimate for a word to be positive, negative, or neutral. So let's go to the logistic regression, a regularized logistic regression, and we are set the probability estimates to true. Okay, so this should train now a word sentiment classifier. Performance is not very good, and this is because, as I said before, in order to get strong, very good word vectors using the tweet centroid model, you need to use a larger corpus, at least 1 million tweets. Okay, of at least 1 million tweets. This is just for demonstration purposes. Okay, so what I'm going to do now is try to deploy this classifier on all the words in this, and all the words we have here, even the missing ones, so we can have now a new expanded lexicon. So to a certain extent, we're now expanding the lexicon we use to label the words to all the words we have in the original corpus. And we expect then that those words are going to be more domain specific. So we can learn now the sentiment of misspelled words or some words or hashtags and words that occur in Twitter. So to do that in Weka, there is a filter called add classification. It's a supervised filter. What it does, and this filter, what it does is this, it trains a classifier on the same data and then adds the predictions as a new attribute. Okay, so as the classifier, we're going to use the same classifier we used before, this filter classifier with the logistic regression, and we are going to output the distribution. So now we'll have the distribution, so how positive, negative, and neutral a word is. And also we're going to remove the old class. We just want to get the new predictions for all the words. Okay, so when I train the model, so now I'm training the model, I'm deploying it. Now I have three more things now. So I have the word name, but now I have a distribution, a score for negative, neutral, and positive. So now I want to turn this dataset into a lexicon, in which I only want to have the word name and the scores for and the sentiment scores. So we do this by removing the attributes that are not very useful now. So all the first ones, and this can be done with the remove attribute, with the remove filter, sorry. So we remove now attributes from the first one, in the range of the first one, until the attribute previous of the word name, which is 4,503. Okay, and this is what we got now. Now we have a lexicon. So now we can see things. So we can see, for instance, the word diet has a strong probability of being negative, the same as bored or criminal. Whereas words like comic, very neutral, college as well, and words like ha are more positive. We have a word like etc., etc. is more positive. So of course those things not necessarily spurious things. Hacks is very positive. So some estimates make sense. So now we have created our own lexicon using the tweet centroid model. And a very cool thing of AffectiveTweets is now that we can use this lexicon to extract features for a new task like sentiment classification. So we can save the lexicon, and we save in the same folder data, and this we can call it the new lexicon. Let's go somewhere else. Let's go to lexicons here. This is my folder of lexicons, ARF lexicons, and I can have here a new lexicon here. New lexicon. Okay, so now I have a new lexicon, and for instance that I can use. So I can go now, I can open a data set here, data. Here I have a data set of just positive and negative tweets, annotated by hand. And now I can use the filter I showed you in the previous tutorial. This one, tweet to input lexicon feature vector. And now we can use the new lexicon here. So, which is the file here, is new lexicon. Cool. New lex. This is the lexicon name. This is going to be appended to the scores we obtain using the lexicon, and we can run this. And now we have tweet level. We have new tweet level attributes using the lexicon we created. And this one is created by just adding the positive, the neutral, and the negative scores. Okay. So we can use this now. So we can remove the content now, and we can maybe train a classifier like a decision tree to predict the sentiment class with these attributes we obtain from this lexicon. Okay, so let's use decision tree J48. And we are obtaining a decent performance. We are learning something. Not perfect, but we are learning something. Of course, if you want to get you want to get good results with this, the lexicon needs to be created from a much larger data set. But we are learning things. Okay. We know that, so we are learning some rules. Okay. So now I will show you a second approach for building lexicons, but this is supervised. So this one allows training lexicons from labeled tweets. Sometimes we have cases in which we have tweets annotated by sentiment, and we would like to have a sentiment score for all the words. So let's open a data set again. Let's go to the original data set here. So here we have again this, so we have a labeled tweets, a labeled data set of tweets. We have tweets, and positive and negative sentiment classes. So the approach we're going to use is called the point-wise mutual information. So this is an association score calculated between words in the corpus and the class. So I will show you here, and it's a very popular and very simple approach for creating lexicons. This is a supervised filter called PMI Lexicon Expander. So calculates point-wise mutual information semantic orientation for each word in a corpus of tweets annotated by sentiment. The score is calculated by subtracting the PMI of the target word with the negative sentiment from the PMI of the target word with the positive sentiment. This approach is a very foundational approach in sentiment analysis. It was created by Peter Turney, and it's a very simple approach, but very useful for creating lexicons. Okay, so what we do here is we have a class here for the tweets, and we declare which is the positive class. It's positive, and what is the name of the negative class? Negative. We run this, and now we have a new data set of words and its semantic orientation score. And so what happens at the end is that positive words end up receiving a very positive score, and negative words a very negative score. Okay, so let's try to see some words here. Let's try to find some. So we have, for instance, the word awesome has a very positive score. And let's try to find the very negative words like beautiful. They're very positive. Why? Because those words are occurring more frequently with positive words than negative words. And let's try to find a very negative word like this. Bored. Obtain a very negative score. So now you can use this one. You can, if you want, you can store this as an R file and then use the tweet to input lexicon to create futures, calculate futures using this lexicon you have created. Okay, that was the second tutorial of how to use AffectiveTweets, but what we did in this tutorial was how to use the package for creating our own lexicons, and then we show that we can also use those lexicons to create futures for any task involving sentiment classification or emotion analysis for social media data. Thanks for watching. See you soon. Bye.